Amniotes adapted to land better than amphibians did. So perhaps it is odd that so many of them then return to an aquatic way of life. Well, perhaps it seems odd unless one considers the mammals, which in general are very well adapted to life on land, but which have evolved to produce dolphins and whales, otters, beaver, and a number of mammals which had to varying degrees adapted to aquatic environments. The same is true of birds. So there are ducks, cormorants, loons, and then even penguins, birds which have adapted to aquatic environments. There are amphibians, which spend their entire lives in the water and retain gills as adults, such as some salamanders. And so while amniotes in general were better adapted to terrestrial life and adapted to land, a number of lineages then adapted to life in the water, such as the lizards in the previous images, the relatives of the tuatara alive today, extinct crocodiles in the Mesosuchian group, and then many other groups which are extinct today. And so it wasn't just that one group of reptiles adapted to marine life. There were snakes which did, just as there are sea snakes today. There are turtles which did, just as there are many aquatic and marine turtles today. And then there are a number of extinct groups. So I would just like to, quickly give an overview of some of these extinct groups of aquatic reptiles, in addition to the aquatic lizards, snakes, turtles mentioned elsewhere. One of the things I always ask my students to remember is that when we talk about the Mesozoic era, and refer to it as the age of reptiles, we often think of the dinosaurs. But there were non-dinosaurs which flew, the pterosaurs, the first vertebrates to fly. And there were a host of reptiles which lived in aquatic environments. So while the Mesozoic truly did have dominant reptiles, they weren't all dinosaurs. From the anapsid reptiles evolved diapsid reptiles by the late Carboniferous. And then by the Permian, a number of small diapsids were beginning to adapt to a more aquatic way of life, it seems, given the flattening of the tail and the modification of limbs often observed in animals adapting to aquatic life. And so in the Permian period, a group of organisms known as ENALIOSAURS were adapting to aquatic life. And from these ENALIOSAURS, is believed that many, perhaps all of the following groups evolved. So by the Triassic period, which is the period which followed the worst mass extinction in the history of life on Earth in the past 500 million years. There were a number of basal placodonts which evolved. Later placodonts would then have dermal bone in their skin, which would form a shell. Some of the shells had a joint in it and two separate segments, while others had one solid shell. And so turtles were not the only group of reptiles to evolve dermal bone to form a shell-like carapace. Certainly, some of the armored dinosaurs went a long way in this route. The adasaurs, which were archosaurs, were herbivores, which had a dorsal armor, but then also these placodonts did as well. One of the interesting thing about placodonts was their teeth, which were modified for the crushing of mollusk shells, such as the armored squid known as ammonites. So here you can see not only are there teeth in the front of the jaw and on the sides, but also on the roof of the mouth. Now, fish can have those, and amphibians and even early reptiles could have those. But in these reptiles, these were then modified, instead of being fang-like to grab prey, they then became these great things which could crush prey, useful for animals adapting to eating mollusks, which often have shells, such as those ammonite armored squid. From the early placodonts, a great diversity in skull shapes and in tooth orientations evolved in later groups. Often think it's of note to remember how much groups can vary. Because, for example, when we compare human teeth to that of a chimpanzee, and our thicker enamel and the reduction of the canines, how significant is that when we compare that to the tooth variations in other groups? The placodonts first arose in the Triassic period and became extinct at the mass extinction at the end of the Triassic period. And that's actually true of a number of these organisms. The Triassic was a time where diverse groups of reptiles adapted to marine life. But the mass extinction at the end of the Triassic period then ended many of these lineages. Mesosaurs included a number of smaller aquatic reptiles, and from mesosaurs, some of the following groups would evolve. So, if one were to consider the plesiosaurs of the later Mesozoic, they were very large, they had flipper-like limbs, and many could have very long necks with maybe even 70 vertebrae. It's important to realize that this could evolve in stages, that even though they seem very well matched to a marine way of life, they didn't have to begin that way. So as we look at the ENALIOSAURS, many were less than 3 feet long and could have many, say just 10 cervical vertebrae in their necks. Later ones would follow, which had more vertebrae in their necks, perhaps some as far as 18 in a group known as the Sauropterygians. Later groups could have 20 to 30, all right? And now some of these could reach sizes of, say, 6 feet in length. And then the plesiosaurs evolved from this group. Now, the early plesiosaurs were small. They were perhaps, say, 6 feet in length and a modest number of vertebrae. But then by, I'm sorry, let's go back to the plesiosaurs. So once again, these animals in this lineage were gradually increasing their size, the neck vertebrae, and their adaptations to marine life. But then by the end of the Mesozoic, these could be 40 to 50 feet long and have more than 60 or perhaps even more than 70 vertebrae in their necks. And so the adaptation to marine life occurred in gradual stages with animals which had some but not all of the features of the later groups. If we were to look at the Sauropterygians and the bones in their fins, they look rather generalized at first with more grasping fingers. But the plesiosaurs would then add additional carpal bones in orange and phalangeal bones in purple, and then modify the ancestral arm into a flipper for swimming. But it was once again a modification of the bones which had previously existed. And so this was one lineage of marine reptiles, and they would end at the end of the Cretaceous. So the end Cretaceous extinction would not only wipe out the dinosaurs, but many other groups of aquatic reptiles which lived at the same time. The mesosaurs mentioned previously in the Triassic period gave rise to perhaps the best adapted marine reptiles called the ichthyosaurs. Now, at first, the ichthyosaurs had more a generalized body plan, perhaps, appearing like a robust crocodilian almost. And it would be later members which would become more shark-like in their body shape. Many of these Triassic forms reached enormous sizes. And so while ichthyosaurs would continue later in the Mesozoic, none would reach sizes of 50 and more than 60 feet as some of these did. And so these ichthyosaurs in the Triassic were huge. And then after the end of Triassic extinction, the ones which survived into the Jurassic had a more dolphin or shark-like body shape and tended to be a bit smaller than those Triassic forms. If one were to consider the arms of the most primitive members of this group, they are a bit more generalized. Later ichthyosaurs then added additional bones and created limbs which were more fin-like and better adapted to aquatic life. So the ichthyosaurs are a group of reptiles which were extremely well adapted to marine environments. Although these adaptations came in stages, the earliest ones had a more generalized body shape and limb form, and they obviously changed over time. The Jurassic ichthyosaurs, could be, 3 feet long, 10 feet long, 20 feet long, and had a more dolphin-like body shape. And although they reached their heyday in the Jurassic period, some did survive into the Cretaceous period. Once again, all of the modifications in this group just seem to be modifications of the ancestral features. So if one were to say, look at the skull bones of a mesosaur, and then ask, well, what did the skull of a primitive ichthyosaur look like? An advanced mesosaur, or a primitive ichthyosaur, or an advanced ichthyosaur, one can see that over tens of millions of years, they were modifications of homologous bones, which gave rise to the more advanced forms. And then there were others. So for example, there was a group of reptiles known as thalattosaurs, which were smaller than some of the other groups, but which had slightly odder body shapes. And if one were to consider the skulls of the basal thalattosaurs, they were modified then to produce a great diversity of tooth shapes, tooth counts, and adaptations. Thalattosaurs, like some of the other groups, became extinct at the end of the Triassic. So the Triassic period is bounded by two mass extinctions. There was a mass extinction at the end of the Permian period, which ended the Paleozoic era. Some of these diapsid reptiles, which were beginning to adapt to aquatic life, survived into the Triassic. And many of these groups then diversified greatly in the Triassic period. But some of them became then extinct at the end of the Triassic period, such as the placodonts, the mesosaurs, the thalattosaurs, the large ichthyosaurs, which had the more primitive body shape. And then in addition, there were semi-aquatic crocodile lookalikes called phytosaurs, which were actually a different group, and others which became extinct in the Triassic period. So reptiles during the Mesozoic era were not only adapting to life on land, the pterosaurs were adapting to flight, and diverse lineages of reptiles were adapting to life in the ocean, but they did so separately and in gradual stages where we can observe body shapes, skulls, and fins slowly becoming better and better adapted to aquatic life.